Hello everyone, my name is William Drescher, and welcome to an Introduction to Computers. Today we're going to be talking about the CPU, or the brain of the computer. Okay, so first off, what is the CPU? CPU stands for Central Processing Unit, and essentially it is the brains of the computer, as I said earlier. It sits on the motherboard, which is the main circuit board of the entire computer. Everything on the computer is connected to the motherboard in some way. Your mouse is connected to the motherboard, your keyboard's connected to the motherboard, and all of that connects to the CPU so that it can control all the other parts of the computer. Now there are two main parts to the CPU. There's the control unit and there's the arithmetic and logic unit, or the ALU. The control unit is basically the working portion of the CPU. It's what does all of the operations that the CPU would normally have to do, other than mathematical operations, which we'll get to in a minute. The control unit is connected to every other portion of the computer. It's basically the part of the CPU that controls the rest of the computer. So if, say, you move your mouse left and right, the control unit tells the operating system that you are moving the mouse around. Now, the other part of the processor, or CPU, is the ALU. There's all these acronyms. In computers, there's always a lot of acronyms. You'll probably get confused one way or another. I always do. I've been doing this for years, and I still can't remember what some of the acronyms mean. So the ALU, or the Arithmetic and Logic Unit, pretty much performs all of the mathematical and logical operations for the entire computer. Every bit of math, and there's a lot of math in computers, every bit of math that the computer needs to do is done in the ALU. So essentially, if you needed to add 2 plus 2, if you have your calculator program in Windows open and you add 2 plus 2, the ALU on the CPU, look at this, all of these acronyms, it's getting crazy now, isn't it? And we've barely gotten into this. That does all of those calculations. It adds 2 and 2, it multiplies 7 and 9, it finds the square root of infinity, which, by the way, yeah, let's not get into that. Let's just skip. Next, moving on. The ALU really only talks to the control unit. The ALU is not really directly connected to anything other than the control unit. So anytime a mathematical computation needs to happen, the portion of the computer that's looking for the answer has to tell the control unit that it needs the answer to this math problem, and then the control unit sends it to the ALU, which then in turn sends it back to the control unit, and the control unit sends it back to the device that asked for the mathematics. Logical operations are a little different than mathematical operations. They deal in true and false statements rather than numbers, which sometimes can equate to the numbers 1 for true and 0 for false. But we'll get to that in a later lesson. Okay, so you may be wondering, alright, the CPU has these two portions, but how do they really work? How does the CPU know what to do? Basically, that's what this cycle is, the fetch, decode, and execute cycle. This cycle occurs anytime a program is running. So basically, anytime you turn the computer on, the CPU is running one portion of this cycle. Sometimes, and we'll get to this a little bit later, sometimes it can be running more than one of these steps at a time. So basically, this is split up into 3 portions. There's the fetch, which is where the control unit reads the next instruction from main memory. Main memory is something like RAM. If you know what RAM is, random access memory, that's main memory. It's what the computer looks at pretty much almost the entire time. It's looking at the main memory unit. And instructions are these little numbers that the processor looks for and pulls in to know what to do next. And they're organized in a list in memory. And so the processor can say, okay, I need to start at 0. Computers start counting at 0. So the CPU says, okay, I need to start at 0, and then I need to read that instruction. And then when that's done, I need to read the instruction at point 1 and then do that one. And that's basically how the CPU knows what to do next. Now, after getting the instruction from main memory, you go into the decode step, which the instruction from main memory is pretty much a number, and any number you could understand in your head. You know, it's like 85. You don't know what that 85, you may know what that stands for. Most people don't know what the 85 stands for, but the processor will take that 85 and decode it and convert it into an electrical signal that it can then send to whatever device needs to be controlled. So let's say the next instruction is 43, and 43 says, you know, turn the screen on. Well, then the processor would read in 43 and say, okay, screen needs to turn on. Turns that into an electrical signal that says turn on and sends it over to your screen. That's a really basic way of telling how this works, but it's enough that I think everybody can wrap their heads around that. This is really confusing sometimes. So, after the decode step, we move into the execute step, and I just explained that just a little bit, but basically, that's the control unit will say, hey, you know, I just read line 18 in the list, and it said, turn the keyboard light on. Not everybody has a lighted keyboard, but turn the keyboard light on, sends that code over to the keyboard, and the keyboard says, oh, hey, I can turn my light on now. Click, turns the light on, and voila, you have the execute step. Now, the processor will always be in one of these steps. It'll constantly, until you turn it off, start at the top, read it, which is fetch, figure out what it does, decode, and then makes it happen. That's execute. And it's just constantly in one of those steps. Now, this is where it gets a little bit complicated. Earlier I said sometimes the processor can be in more than one step at any time. That's where multi-core CPUs come in. A CPU core contains both an ALU and a control unit. Since you have more cores in the CPU, which multi-core usually means there's more than one, you can have 2 cores for dual core, 4 cores for quad core, 6 cores for hex core. You know, it's usually a multiple of 2. It's not always true. Sometimes you can get odd numbers, something like 3 cores. That's kind of a Intel makes a couple of processors with 3 cores in it, I think. But each core has an ALU and a control unit. So the 2 processor cores can each do an instruction at a time. So if processor 1, or I should say processor 0, remember computers start counting at 0, core 0 fetches the first line of code, core 1 can fetch the next one, and then they both can do the steps at the same time. This is a little confusing. It's kind of a little hard to wrap your head around, but if you think about maybe something like using both hands to type on a keyboard rather than one hand. So maybe you type, you try to type hello, and you've got H, then the E, then the L, and then the O, and you're doing that with one hand. It's kind of slow. But if you're a touch typer and you have 2 hands, you can quickly pass in between each key even faster than you would have to do with just one hand. And essentially, having more cores makes the CPU faster because it can do more things at once. Now, the next portion that we're about to talk about is a little more complicated. It's kind of a glimpse at the upper levels, and I just want to kind of quickly run through it. It's kind of an advanced basic, really. So it's not important to really know exactly how CPUs work with this bit of information, but I think you guys will really like it and would like to know exactly what these terms mean. Okay, so you may have heard in the span of buying a computer, using a computer, downloading software, they ask you, are you 32-bit or are you 64-bit? And you may have stared at that thing for 10 minutes and thought, oh gosh, I have no clue what those mean. Or maybe I don't know if my computer is either. I got it as a present maybe. I don't know what this computer is. 32 and 64 are what are known as architectures, or at least a portion of an architecture. CPUs handle numbers in bits of memory. A bit is a squished together word. It means binary digit. And a bit is either a 1 or a 0, on or off respectively, in the computer. Now, numbers in a computer are represented by patterns of bits, like saying that 1101 in a CPU means a certain number. So whatever the pattern may be, that's what the number is, and that's what the CPU recognizes as, okay, this pattern is this number. That's how computers can understand human numbers. I say human, logical numbers. So the highest logical number a CPU can understand is determined by the highest bit amount the CPU can understand. That's a very confusing little statement there. Let's say you have 32 bits. Each one, in 32 bits, you make a pattern to make a number. Well, if all 32 bits are all ones, that is the highest number the CPU can natively understand. That natively means it doesn't have to put another 32 bits on the end of it. A CPU can essentially understand any number if you squish a bunch of blocks of 32 together. It's kind of like when you're trying to fill a glass of water with a pitcher. You can line all the glasses up together and pour the pitcher across all of them, but it doesn't all fit in one glass. So essentially, your pitcher is your number, or the water in the pitcher is the number, and each glass is a set of 32. So when you pour the water into one, as it gets towards the top, you got to go over into the next one so that it doesn't spill over. That's what a CPU does when it tries to understand numbers. There's a little bit of information here. A 32-bit CPU can understand any number between negative 2 to the 32nd minus 1 and positive 2 to the 32nd minus 1. Those are just statistical numbers, or not statistical, but they're just logical numbers to kind of give you an idea of what number the CPU can understand. But a 32-bit CPU can understand numbers larger than that. It just needs another glass to fill to count more numbers. Now, a 64-bit CPU can understand essentially double that amount, but at an exponential number. As you can see, it understands anything in between negative 2 to the 64th minus 1 and positive 2 to the 64th minus 1. Lots of numbers. It's probably getting really confusing. Feel free to pause the video, go back, listen to that again, or maybe go get a soda and think about this for a minute. This is a really hard subject for some people to understand. If you take a glass, let's say that you have those glasses and you were pouring water into them before, and those are 32-bit glasses, and you have a big number. That pitcher is completely full. Well, now we have a 64-bit computer. So let's say you needed 4 glasses originally to store all the information from the big number in a 32-bit CPU. You needed 4 glasses. Well, now you have a 64-bit CPU. You only need 2 glasses now because the glasses are bigger. They hold more bits. So you can pour that entire pitcher into 2 64-bit glasses instead of 4 32-bit glasses. Ooh, okay. I think we got through that. That was a lot of numbers, and that was, oh my goodness, if that was not confusing, I congratulate you, because even when I heard that the first time, I was completely confused. Okay, so let's review. The CPU is the central processing unit. It is the brain of the computer. It has 2 pieces, the control unit and the arithmetic and logic unit, or the ALU. It runs in a fetch, decode, execute cycle, and the CPU is always in one of those steps. Multi-core CPUs can be in more than one of those steps at any point in time. And 32-bit and 64-bit CPUs are different types of architectures, or parts of the architecture. There's a lot more to architecture that will be covered in a more advanced tutorial or lesson. But 32-bit and 64-bit hold different amounts of data. Alright, that's all I have for this lesson today. If you have any questions, leave a comment below or feel free to shoot me an email. It's wilkuacode@gmail.com. I'll try to answer as many questions as I possibly can. In the next lesson, we're going to take a look at main memory. Now, I talked a bit about main memory back in another slide. You can rewind the video and go look at that a bit. I talked a little bit about it. It's basically the random access memory of the computer. I won't get into it now. You can go check out the video. It's basically the thought processes of the computer. It's where the computer remembers things about what it did 5 minutes ago. So in the next lesson, we'll talk about that. And you guys should all have a great day. Make sure to leave a comment, questions, anything, and shoot me an email. See you guys later.